Alright, welcome to lesson 4 of module 4. Our objective today is that by the end of the lesson you'll be able to solve a linear equation by applying different properties of equality. So you'll know you're successful today when you can apply those properties of equality to find a solution to a linear equation. We're going to review a few different properties, then I'll do 3 examples for you. You'll have, I think, 5 exercises, and then we'll kind of close out the lesson before you do your exit ticket. Alright, just to review some properties of equality, basically these properties in math, or these laws in math, tell us that whenever we do something to one side of an equation, we have to do it to the other. Okay? So we have addition property of equality, subtraction property of equality, multiplication and division. And I'm just going to give you a few little examples because this is how we're going to justify our work today. So if I had 5 plus 2 equals 7 plus 0. And this is true because 5 plus 2 is 7. 7 plus 0 is also 7. The addition property of equality says that if I add something to both sides, it's going to stay the same. So if I add 1 to this side and I add 1 to this side, it's still going to remain balanced because I did it to both sides. It stays equal when I add the same number to both sides. So if I do this, it would stay equal. It would become 8 equals 8. Okay? Subtraction property of equality says the same thing. So this again would be 1 plus 5 plus 2, 7 plus 0 plus 1 now. Again, subtraction property of equality says the same thing. So if I were to subtract 3 from both sides, it would work out to be the same. So if I took away 3 here, that would be taking away 1, 2, it just equals 5. On this side, take away 3, this is 4 plus 1, which would also be 5. Again, it's staying equal. If I multiply both sides by 2, it's going to remain equal, right? This becomes 10, this becomes 10. And same if I divided both sides by the same number, it is going to remain equal. Okay, it's going to remain balanced. So these are our properties of equality. Again, if you do one thing to one side, whether it's add, subtract, multiply, or divide, your equation is going to stay the same if you do it to the other side as well. So that's how we can manipulate these problems to solve for our solution. All right, we're going to get started. We're just going to go ahead and solve this. So the first thing I want you to do is draw your line through your sign. This will keep you organized as you go, and you'll remember, okay, I did this on the left side. Do I see it on the right side? It allows you to kind of find some of those mistakes. So the first thing I do when I solve these problems is I look for my variables. And those are what I want to be by themselves. I want my problem to read something that says there's only an x on one side and then it equals something on the other side. Okay? So I'm going to try to move all my x's to one side and all my numbers, my values, to a different side. So the first thing I want to do, I'm going to start with this minus 3. And remember, we can start with anything we want. So I'm just going to move that to the other side. I'm going to get that away from my x right here. So I'm going to do the opposite and do plus 3. You could start with anything else. Okay? That was my first step, and I used the addition property of equality because you can see that I added to both sides. This cancels. I'm left with 2 x's over here. On this side I have 4 x's plus 3. Okay? Now again, I'm trying to get those x's together. So I'm going to move those 4 x's over to the other side. So I'm going to take 4 x's away over here. And I'm going to have to do the same on this side. Now I just use my subtraction property of equality. Over here this cancels. I'm just left with 3. Over here, if I have 2 x's and I take away 4, I'm at a balance of negative 2 x's. Okay? Alright, next I want to get that x by itself. Right now it's being multiplied by the coefficient of negative 2. Right? This says negative 2 times x. So the opposite of that would be divide by -2. Again, I'm trying to get my x by itself, so this is how I get it away. And I have to do it to both sides to keep this balanced. All right, on the left side, those cancel out. I'm just left with x, which is what my objective was. On the right side, you could either simplify this, okay, or you could leave it as an improper fraction, or you could turn it into a mixed number. It's up to you, but my answer is going to remain as -3/2. I'll give you the alternative to that. This is the same as -1.5, or this is the same as -1 1/2. Okay, and again, you don't have to write all those answers. I'm just showing you each one. So again, going through here, first, right up here, I use the addition property of equality. Then I use subtraction property of equality. Then I use division property of equality. Okay, right, I divided just using that fraction sign. And by using all of those, I was able to simplify this and get my solution. All right, step 1 is to draw a line through your sign. Next thing I like to do is identify where's my variable. What am I trying to get by itself? All right, so this x has a 3/5 being multiplied by it, and it's being subtracted by 21. So the first thing I think I'm going to do is just move this 21 to the other side, or cancel it out by using my addition property of equality. Okay, on the left side, these cancel. On the right side, 5 plus 1 is 6, 1 plus 2 is 3. Okay, everything else on this side stayed the same. Okay, next step. My x is still not by itself. As you can see, it's being multiplied by 3/5. So to get it away, I'm going to divide by 3/5. Okay, and on this side, I'll do the same. I will divide by 3/5. This is my division property of equality. On this side, it cancels. I'm just left with x. On the other side, it's a little bit more complicated. So when we divide fractions, you learn this in 6th grade, you use this strategy called keep, change, flip. Okay, you might have called it something else, but it's essentially the same thing. You keep that first term, you change your sign to multiplication, and then you flip your fraction upside down. So now I'm just going to multiply this straight across. 36 times 5 and 1 times 3. I'm going to do 36 times 5 off to the side. You can do it on your calculator. 5 times 6 is 30. Carry the 3. 5 times 3 is 15, plus 3 is 18. So this becomes 180 over 1 times 3 is 3. So 180 over 3. Again, that simplifies pretty quickly. I would not want you to leave it as this high of an improper fraction. 180 divided by 3 is or over 3 is the same as 180 divided by 3. And you could do that multiplication or that division in your head. You could do it, on pen and paper. You could do it in a calculator. But essentially, this simplifies. 18 divided by 3 is 6. And then we just keep our 0 because 0 divided by 3 is 0. So this is the same as 60. So our x equals 60. If we wanted to check our answer, we could plug this back into our original problem up here. And it would prove that the left side equals the right side. All right, this is the last example we're going to do before you jump into your work today. It's been a pretty simple lesson. This is pretty much review from 7th grade. All right, we're going to try to get these x's all together. Okay? Now, how you go about this, again, it's up to you. You could start with subtracting, you could start with adding, you could start with multiplying or dividing, you could combine like terms. It is completely your choice. I'm going to try to show you the easier ways to do it. And as you get better in math and you get more familiar with it, you'll be able to catch on to those easier ways. So I like to make sure that I don't make any negatives for myself. I try to stay away from doing big division or multiplication problems. So the first thing I've decided I'm going to do is I'm going to subtract 13 from both sides. I'm going to use my subtraction property of equality. Over here it cancels. Everything else on this side stays the same. 1, 5x plus x equals 1, take away 9x, and then I'm doing that 22 take away 13. 2 cannot take away 3, so I borrow. 12 take away 3 is 9. And 1 take away 1 is 0. So I have simplified this a little bit more, but there's still quite a ways to go. So at this point in time, I'm just going to do something that doesn't really, it's not using my properties of equality or anything, but I don't like having this subtraction sign on the right here. So I'm going to do keep change opposite and turn this into a plus sign. So this is just going to become keep change opposite. And that's just so that I can work with easier numbers and I don't have to try to do like a double negative anywhere. All right, from here, I'm going to move this 9x to the other side. So I'm going to add 9x's, and I'm going to add 9x's. Over here, this cancels. I'm left with 1 plus 9. On the right side, I have my 1/5 x plus, I add 9x's and then another x, so this is now 10 x's. Okay. Now that I have all my variables on one side and my numbers or my constants on the other, I can just combine like terms. I don't even have to use any properties of equality. So 1 plus 9 is 10. And on this side, 1/5 x plus 10 x's is 10 and 1/5 x's. Okay. Now right now, to get my x by itself, I would have to divide by 10 and 1/5, because right now it's being multiplied by that. So again, I'm trying to get this x by itself. Right now it's saying times 10 and a half, or 10 and 1/5. So I have to divide by 10 and 1/5. And I'm going to do this to both sides. On the left side, it cancels out. I'm just left with 1x. I'm almost done. On the right side, 10 divided by 10 and 1/5. So you could do a few different things here. You could turn 10 and 1/5 into a decimal. 10 and 1/5 is the same as 10 point, and we're going to do 1 out of 5. So if we split the decimal 10 into fifths, this would be 10.2. Okay? So I could either turn that into a decimal. I could turn it into an improper fraction. This would be 10 times 5, 50 plus 1, 51 over 5. Okay. So I'm going to, for this, I'm just going to do the improper fraction. That'll be easier for me to show my work. So it's going to be 10 divided by 51 over 5. And when I divide fractions, I do keep change opposite. And then I multiply across. 10 times 5 is 50. 1 times 51 is 51. So this becomes 50 over 51. This doesn't simplify mathematically. You could turn it into a decimal if you want. You would just divide 50 divided by 51. And so like my decimal came out to 0.98 when I rounded off. And to check your work, you would just have to plug this back in for x and see if the left side balances to the right side. All right, these are your exercises for today. This is where you're going to get your practice work in. As always, I want you to solve these on your own. Pause this video where I'm explaining them. Solve them on your own, and then when you're done, check your work by pressing play on the video again, okay? So each of these is going to have you solve an equation and then tell me the first step that you used. So maybe you use the addition property of equality first. Maybe you use subtraction property of equality, or multiplication or division. I just want you to tell me which one you chose first. It does say to explain why you chose it. You don't have to tell me why. It's just up to you which step you choose to do first. So you're going to do 1 through 5 right now. Pause this video and then come back to watch me go over the answers and check your work. All right, by now you should have solved these, and you're coming back to press play and watch me do them. Starting with exercise 1, I'm going to just start by drawing a line through my sign, and then I'm going to first just combine these like terms on this left side. I have 1, 2, 3, 4 x's. So I'm going to change this to 4 x's. And then I have 2, 4, 6, and they're all being added, so this is 12. Okay, so the first step I did here was just combine like terms. And I chose that because it just made my problem a lot simpler to begin with. All right, next thing I'm going to do is I'm going to take away 12 from both sides. Again, our steps might not look the same. Over here it cancels, I'm left with 4 x's. Over here, negative 28 and a negative 12 is going to give me negative, add these up, 2, 3, 4, negative 40. All right. Last step, still trying to get this x by itself. Right now it's being multiplied by 4. To get that away, I will divide by 4. Divide by 4. On the left side, I'm left with just 1 x. On the right side, 40 divided by 4 is going to be 10, but I do have that negative sign. So negative 10 is my answer. All right, hopefully no questions there. And again, my first thing that I did was combine like terms. And it made it simpler. I'll show my first step up there. All right, number 2, solve a linear equation, state the property that justifies your first step. Draw a line through my sign. All right, the first thing I'm going to do here is I'm going to distribute this 2, because again, that's part of simplifying my equation. 2 times 3x, 6x. Keep my plus sign. 2 times 2 is 4. Everything else on the other side stayed the same. Okay, next step. I have some like terms on my right side that I can combine. 2x's plus 1x is 3x's. Okay, now I'm going to use my subtraction or my addition property of equality to move this 1 over. This becomes 6x plus 5. Over here, this just becomes 3x. And then I'm going to use subtraction property of equality, take this 6x away. I'm left with 5 equals 3x's, take away 6x's, that's going to give me negative 3x's. My last step here is to divide by that coefficient, get my x by itself, so divide by negative 3, divide by negative 3. I'm going to continue my work up here. This becomes negative 5 over 3 equals x. Okay, so that's my answer. I could turn that into a decimal if I wanted, turn it into a mixed number if I wanted. So if I do 5 divided by 3 as a decimal, that's 1.66 repeating. Those are my answers. Same number, I don't care how you show it. The first thing that I did was I distributed. I used the distributive property. And I did that because it helped me simplify. Okay. Number 3, draw a line through my sign. Right now I have x take away 9. I don't like that minus sign, so I'm just going to use keep, change, opposite, and turn that into a plus sign so that I can move things around. So I do this, guys, because in math, you can change the order of things if you're adding them or multiplying them. If you're dividing them or subtracting them, order matters, so you can't change the order around. But it's super easy to just turn subtraction signs into addition signs, and it's super easy to turn division signs into multiplication signs, and you learned that in 7th grade. So that's what I just did right there. All right, next thing I want to do is I am going to try and get all my x's on one side. So I'm going to take away this x from over here, so it then moves to this side with the other x. Over here this cancels, I'm left with -9. Over here I have 3/5 x take away another x. Now this is kind of hard because I'm working with fractions. I'm going to show this work right here. So I have 3/5 of an x take away 1x. Now to show 1x, I could just write it like that, right? Or I could just leave it as an x. But I'm going to show it as 1/1 because that's the same thing, okay? And it allows me to have a fraction so that I can subtract. Now, when I subtract fractions, the denominators have to be the same. Right now, this is a 1, this is a 5. So I'm just going to turn that 1 into a 5 by multiplying this by 5. So this becomes 3/5 x minus, and if I do this whole thing by 5, times it by 5, this becomes 5/5x. Okay? And now that they have the same denominator, I can actually subtract. If I do 3 take away 5, this becomes -2. And then when you subtract fractions, you don't subtract the denominators, it just stays there. Okay? So 3/5 x take away 5/5 x is -2/5 x. So that is my answer here. Again, if you wanted to, you could absolutely turn these into decimals, do them in your calculator. It might be a lot easier. All right, last step here is to get my x by itself. Right now it's being multiplied by -2/5. So to get that away, I'm going to divide by -2/5. Over here it cancels, I'm left with x. And over there I have to do the math. I'm going to do it down here. -9 divided by -2/5. I'm going to have to do keep, change, opposite, or sorry, keep, change, flip, because I'm dividing fractions. Keep, change, flip. And then I'm just going to multiply straight across. -9 times -5. Negative times a negative is a positive. This becomes positive 45. And then on the bottom, 1 times 2, 2. So 45/2 is my answer, equals x. I could also turn this into a decimal, or I could turn it into a mixed number. So if I did turn this into a decimal, 45/2 would be 45 divided by 2, and that equals 22.5. Okay, so either of those work. The first thing I did, my first real step, I did do keep, change, opposite at the top, but I used the subtraction property of equality right here. That was the first step I did. I'm not going to write it down though. Okay, number 4, draw a line through my sign. I'm going to go ahead and just start this one. So it says -3x. I'm going to move that to the other side. I'm going to do +3x. So I'm going to use my addition property of equality. Cancels, I'm left with 29. Equals 5x's plus 3x's, 8x's plus 5. Next thing I'm going to do, subtraction property of equality, trying to get these x's by themselves. Take away 5 from both sides. Sorry, my 5s look like s's. 29 take away 5 is 24. So 24 equals 8x. Trying to get this x by itself. Right now it's being multiplied by 8, so I will divide by 8, divide by 8. This side it cancels, I'm left with x. This side, 8 goes into 24 exactly 3 times. So that is my answer. And the first thing that I did was the addition property of equality right here. Okay, you could have done anything. That was number 4, pretty quick. All right, last exercise here that I'm going to go over with you is number 5. I draw a line through my sign. I am going to first try to get this minus sign out of the way right here. I don't want that minus sign there, so this becomes keep, change, opposite. What's cool is that this x is already by itself over on the right side. So that's awesome. I'm going to have to move this other x over there. So right now it says plus 1/3 x, so I'm going to have to do minus 1/3 x. Over here it cancels. I'm left with negative 5 plus 171 equals, I have 1x and I'm taking away 1/3 x. So 1x minus 1/3 of an x. If I'm subtracting, I need both of these to be fractions and I need them to have the same denominator. So this denominator is a 3, so I need to change this to a 3. To get through a 3, I would have to multiply by 3. So I have to multiply both sides by 3, so this becomes 3 over 3x minus 1 over 3x. 3 take away 1 is 2. So this becomes 2/3 of an x. Again, you can turn these all into decimals and work with decimals if you'd rather. It makes it easier on a calculator. All right, last thing I'm going to do over here is combine these like terms. Well, not the last thing I'm going to do, but last thing I'm going to do on the left side, I think. And so I have a negative 5 plus a 171. That's the same as saying 171 take away 5, okay? Do it on my calculator real quick. This becomes 166 equals 2/3 times x. Now I'm still trying to get this x by itself. Right now it's being multiplied by 2/3, so I'm just going to have to divide by 2/3 on both sides. Over here it cancels. I'm left with x equals 166 divided by 2/3. Now if I do that over here, 166 divided by 2/3. I'm dividing a fraction, so I have to use keep, change, flip. Times keep, change, flip. Now I'm just multiplying. 166 times 3. I'm just going to quickly do that in my calculator. I get 498. 2 times 1 is 2. I don't want to leave this huge improper fraction because I can see that it's going to go evenly. So 498 over 2 is the same as 498 divided by 2, and that equals 249. That's my answer. And the first thing I did up top was I used the subtraction property of equality. That was my first step right here. We're done with our exercises. All right, just to close out and review the things we did this lesson before you do your exit ticket, we use properties of equality to simplify our equations, make it easier for us to solve, and to kind of break it down so that we can get x by itself. In addition to these properties of equality, we also always want to make sure we distribute when we can. We want to make sure we combine like terms. We also want to make sure that we are using strategies like keep, change, flip to get rid of subtraction signs. Or sorry, to get rid of fractions when we're dividing fractions. And we also want to use keep, change, opposite to get rid of subtraction signs or negative signs so that we can move things around. All right, we're going to move on to your exit ticket now. All right, here's your exit ticket for today. It is 3 questions. You are literally just doing exactly what I just showed you. You are solving for your variable. Okay? The first one does say guess a number for x. You don't need to go through all that and guess and check. I just want you to solve for x. Okay? And it does say check your solution. I can't really force you to do that, but I don't know why you wouldn't if this is your exit ticket. Check to see if it actually works when you plug it in. Okay? Number 2, use the properties of equality to solve. State which property justifies your first step. Check your solution. So just tell me what step you use first. You could even just put an arrow and point to it so I can see it. But it should be clear enough where I can see that first thing you did. And again, check your solution before you move on so you know that you're correct. Third one, same exact thing. Solve. Tell me what property you used first and check your solution. All right, when you're done with this, then the lesson will be over and you'll move on to your reflection in Google Classroom.